The logic governing our software is shifting. While traditional applications rely on human-authored workflows, autonomous agents are beginning to dominate web traffic, operating on a declarative model where they define outcomes and execute the intermediate steps themselves. As the two agents appear, these autonomous actors interpret human intent to independently settle trades and negotiate liquidity routing directly across decentralized networks. Major institutions are already adopting these frameworks. In June 2025, VivoPower converted $100 million of its corporate treasury into XRP and deployed it via Flare's F-Assets infrastructure. They did this because the system is backed by verifiable cryptographic hardware, which removes the need for manual human oversight. We will demonstrate how to deposit native XRP into a hardware-enforced private vault to mint programmable FXRP and begin earning yield. This process provides the essential infrastructure required to securely delegate capital to AI in the agentic era. Because autonomous agents execute transactions at machine speed without human oversight, they are high-priority targets for automated cyber exploits. In this environment, an attack can spread through a decentralized network in minutes. To counter this, developers use confidential computing. This technology physically isolates an agent's logic and data from the cloud host, ensuring that even if the host system is compromised, the agent's calculations remain untampered. Inside the server, a trusted execution environment acts as a secure enclave, using hardware-level encryption to seal off the agent's code and private keys. Within this enclave, the Denarii orchestrator runs a Guardian shield, actively blocking prompt injections and preventing unauthorized extraction. By confining the execution entirely within these isolated processors, the network provides a physical guarantee that the agent's financial logic has not been altered. Step 1 is authorizing the network to interact with your assets. Open your Flare Smart account and call the Approve function. You will provide a digital signature to authorize the specific amount of native XRP you want to deploy. Next, execute the Deposit function. This locks your native XRP and sends a standardized deposit instruction to the decentralized network. Your deposited XRP routes into the core vault. These pooled, high-efficiency structures handle millions in capital. While infrastructure providers manage collateral, no single agent owns the vault's assets. They can request assets for operations, but are physically blocked from unauthorized withdrawals. This shared vault design maximizes capital efficiency for the network, while ensuring that individual balances remain private by default. After clicking Deposit, you must wait approximately 90 seconds. The Flare network operates on an anchor epoch, meaning it verifies and commits external transactions to the chain every minute and a half. During this window, an enshrined network protocol called the Flare Data Connector is at work verifying your external deposit. The data connector scans the external XRP ledger to mathematically prove your deposit, generating a verified checkmark. Independent data providers vote to agree on this proof. Once majority is reached, the instruction enters the hardware enclave, minting your programmable FXRP. Because the minting requires this consensus-level verification, your FXRP is a trustless, mathematically proven representation of your underlying capital. With your FXRP minted, you can now generate a return. Navigate to a decentralized lending market like Morpho or the Firelight Liquid Staking dashboard to deposit your new tokens. By staking your FXRP, the protocol issues you STXRP, which begins accumulating programmatic yield automatically. Because these retail pools and institutional treasuries both settle on the same F-asset infrastructure, your capital utilizes the same audited smart contracts and collateral rules as a 9-figure corporate treasury. To secure these markets, the network employs an automated safety net. If an infrastructure agent attempts to move the underlying collateral without authorization, the system reacts at machine speed. The data connector constantly monitors the ledger addresses. The moment it detects an unauthorized withdrawal, it registers a balance decreasing transaction and triggers an immediate liquidation of the agent's own collateral to protect the users. This real-time telemetry ensures the network never has to trust the agents. It verifies them continuously and enforces immediate penalties, keeping your capital protected. You have successfully bridged a legacy asset into the autonomous machine economy, using hardware enclaves to securely mint a programmable counterpart for yield. Your native capital rests safely inside a locked cryptographic vault, while its programmable representation works across decentralized protocols to compound your yield. The hardware isolation and consensus checks we navigated today are the exact mechanisms being built to support these autonomous agents. By establishing this architecture now, you hold the verifiable infrastructure required to safely let AI agents operate your portfolios in a decentralized future.